From current slide, Windows P, duplicate, boom. All right. So 3 tangent squared x minus 1 equals 0. Since you only have the squared, you solve this like a square root, which means you don't factor. You solve it just like a regular equation, and you solve the square part at the end. So how do we get rid of the minus 1?
Add 1.
We got 3 tangent squared x equals 1. How do you get rid of the multiplication by 3? So we add 1 to both sides, then we divide both sides by 3. And now you got tangent squared x equals 1/3. Now this goes to what Jada asked about, are we ever never going to need to do trig? Well, some people were dismayed yesterday because from this point on, it's the unit circle. So you need to recall. Well, no. For this part of the equation, from solving the equation, this part on involves the unit circle. In other words, how to get rid of the square? You do what to both sides?
Square
root. So tangent x equals plus minus 1 over root 3. And then we got to rationalize that denominator. All right, which should be root 3 over 3. Oops, it's there. I didn't trust myself. Yes, you do, Jay. What's up, Brian?
So you don't have to do like square root 1 over 3.
Hold on.
1 over 3. Not 1 over 3. Square root 1.
It's the square root of 1 over the square root of 3. What the heck just happened? What on earth?
Okay.
No, it isn't. I'm so tired of it. I'm so tired of all of it. Hold on. There we go. Okay, I fixed it. He's kind of right on there. Okay, so we'll go back to this. All right, so we find the square root, and we include the plus minus symbol. So it's plus minus 1 over root 3. And as Jay was talking about, we rationalize the denominator, and we end up with root 3 over 3. But with a plus minus in front of it. Now, the good part about this is what it removes is the questions about where is tangent positive and where is tangent negative. You don't really have to worry about this because it's not going to matter. Because now you're dealing with both the what? The positives and the negatives. So x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So you have to remember that tangent is root 3 over 3 in the pi over 6 family. Tangent is positive in the first and third quadrants. So that's the pi over 6 and the 7 pi over 6. And then it is negative in the second and fourth, so that's the 5 pi over 6 and 11 pi over 6. It's meant.
So for like our answers that we have these problems, is it just these answers?
There's different types of problems. Okay, there's the general solution that we're going to talk about in a second, and then over the interval 0 to 2 pi. So basically, see how it says on the top, over on the interval 0 to 2 pi?
Yeah.
Then these are your answers. Okay?
So just try to remember to do 2 steps at the end.
What do you mean?
Like find whatever
the two values are.
Yeah,
right?
and then find the values for it.
Yeah, so basically you're going back to like we said the unit circle. Alright? Nobody.
The last part, I was writing down that stuff and then that part popped up. Like
Whatever you need, dude. We don't. The what?
The pi over 6 part, what was that again?
That comes from where it's tangent equal to root 3 over 3.
Okay.
So this goes back to unit circle. So you have to then, and if you want to have that out when you take this quiz, feel free. That table we had, where is tangent equal to root 3 over 3? You know what I mean? And that's boom. Because we're not retesting you in the unit circle, we're testing on solving equations. So if you want to use that right in front of you as a reference, go right ahead. All right? So that's the last part, identifying the values. Now, if they're talking, okay, so that would be the answer to that. So you don't have to write this down. But this is a review of what happened yesterday. So if you didn't pay attention yesterday at home, when they talk about general solutions, what we do is we add plus minus and then n times whatever the period is. The period for sine, cosine, secant, and cosecant, just like it is when we graph, with 2 pi. for tangent was just pi. So basically, if they ask you to do a general solution, it would be pi over 6 plus minus n pi, and 5 pi over 6 plus minus n pi. Why? Because if n was 1, what's 1 times 6? 6. What's 6 plus 1? 7. Yep, so there's the 7 pi over 6. 5 pi over 6 plus 1 would be 11 pi over 6. So you need to go back and check that if you have a question about general solutions versus specific. Or read it in your book. This is section, I think, 5.3 in your book. It's in there as well. But you need to make sure you know the difference. Because in tonight's homework, the one that's actually due tonight, first group is 0 to 2 pi. The second group is general solutions. The third group is 0 to 2 pi. And if you don't do it on a homework, it's not great, but it's not going to destroy you. But if you don't do it on a quiz, then it's going to be a bigger problem. All right? Any questions?
So, like the pi is like 1 pi over 6, that's why that ends 1.
So here's the idea. Okay? So basically, if you recall the unit circle, okay, we always come back to the same value. So pi over 6 is here. So anytime we come back to there would be a solution. So 13 pi over 6, 25 pi over 6, all that. Well, here's what works with tangent. In the opposite quadrants, they're the same values. Positive, positive, negative, negative. So the pi over 6 and the 7 pi over 6 are the same. So I don't need the 2 anymore, I just have the 1. So pi over 6 plus the n pi, like you just asked, there's the pi over 6, there's the plus 1 pi. And then when we added 2 pi, where would we be back there and then? You know what I mean? Over and over again. The negative was, the first one was the 5 pi over 6. And if I add 1, I'm at 11 pi over 6. So with tangent, you don't have to do 2 pi, you only have to do pi. With tangent and cotangent, it's just pi. With everything else, it's 2 pi. All right? Yes, ma'am.
So basically, would both of those answers be right, but the one on the bottom is just like the general?
This is what the answer to this problem would be the way it's set up, because they say interval 0 to 2 pi. I just went through this because you guys weren't here yesterday, and in case you didn't understand that, in prepping for tonight. You know what I mean? So this would be the answer to this problem that's in front of you. This was just to review that concept for everybody. All right? For sine squared x minus 3 equals 0, what would you do first?
Add 3 to both
Add
sides.
3 to both sides. What would you then do to both sides? Divide by
4.
4. So you have sine squared x equals 3/4. Then how would you undo the square?
Square root.
Square root. And you'd have the square root of 3 over
4.
2.
Oh,
2, because you have to do the square root of 4.
2.
With a what symbol in front of it?
Plus
Plus
or minus.
minus. As soon as you see sine and root 3 over 2, you should be thinking of the pi over 3 family. So pi over 3 and 2 pi over 3 is the positive. 4 pi over 3 and 5 pi over 3 is the negative. That would be over the interval 0 to 2 pi. If it asks for the general solution, it's pi over 3 plus minus n pi, 2 pi over 3.
Well, what do we put in for n?
And is it anything you want to do? Remember when we did asymptotes and all
Yes,
that?
but like, how do we know which number to put in now?
It's not a number.
Oh,
You
just
just
the
do
n?
the n.
Oh, perfect.
Because n can be any number.
Okay, perfect.
So n can be any number.
I have a question.
I got you.
So, like, we're not just looking for the root 3 over 2 in the whole thing, right?
What do you mean?
Like, in the whole unit circle, are we looking for the root 3 over 2
All,
anywhere?
but you have to figure out where, you have to remember where was sine equal to root 3 over
And
2.
then when I find that,
That's the
number.
pi over 3 family. And then you have to remember where,
The signs of the
so here's my unit circle.
Yes.
So sine x is positive root 3 over 2, right here, pi over 3. Also there, 2 pi over 3. So those are the two positives.
Okay.
And then it's negative down here.
So Correct.
So it's the pi over 3, the 2 pi over 3, the 4 pi over 3, the 5 pi over 3. So when you get one like this, without factoring is different. But when you get the plus minus, just remember it's all 4.
Okay.
You know what I mean? It's kind of easier to remember that because you don't have to distinguish from the plus
And then when we write the bottom part, we just take the first two numbers, right?
Yes, you can.
Alright.
All right.
Okay.
Good. All right. Now, factoring and a trip down memory lane. You don't have to write this down. Okay, because I don't think this is in your notes. Or is it? Yeah, I didn't put it in your notes. I just want to remind you, if you had to factor, that was the whole factoring process. You got your 2 binomials, right? And then what was the opposite of -2? 2. What was the opposite of that? 4/5. So those were your 2 solutions. You're going to do the same thing. Now, where does the 2 and the 4/5 come from? Setting each factored polynomial equal to what? 0. It's the same idea. You got me? So I'm just showing you that as an example so you remember. Part of the process was we had a quadratic. We factored it using any method you want, grouping, guess and check, slide and divide. You got your 2 binomials, and either in your head or on paper, you set each binomial equal to 0 and solve. All right? We're going to do the same thing. Set each factored expression equal to 0 and solve. You just got to fill in that one blank. Set each factored expression equal to 0 and solve. All right. Did thus far? Okay, so we got cotangent x, cosine squared x equals 2 cotangent x. You recognize that both sides of the equation have a what in it, the cotangent x. So I'm going to get it equal to 0. So cotangent x, cosine squared x minus 2 cotangent x equals 0. So I get it equal to 0.
Why can't you divide straight like from the beginning?
You can, but it's going to create, we're going to compare it to something we did yesterday.
Okay.
Now that you saw it, you don't get all the solutions that way. So this way you get all the solutions. That's why. To answer your question, because if you don't factor it out, you'll see. Like if you have something equal to 0. So basically what we're going to end up with is a cotangent x equal to 0. If you just cancel it out, you lose that. You know what I'm saying? So you lose some of the solutions. I understand exactly why you're doing it because that's the way we did it yesterday.
Yeah.
We're not going to do it that way anymore. Okay, now they both have a what in it, a cotangent x, so I factor that out. All right? So that'll look like that. Cotangent x times cosine squared x minus 2. So the first thing you look for is see if you can factor out a GCF, which you can. God bless. All right, this is all you do from there. You take each part of your factored expression. So one part is what? The cotangent of x. The other one is what? Cosine squared x minus 2. You set each part equal to 0. So if I set cotangent x equal to 0, that occurs at pi over 2 and 3 pi over 2. That's where cotangent, so you just, cotangent x equals 0, and we go back to the unit circle. Cotangent is 0 where cosine is 0. Cosine is 0 at pi over 2 and 3 pi over 2. I'm going to try to post that chart again today. Remind people that of what the values are. If I get time, I got to write a quiz first for another class.
Read the square root of this now.
What's that?
Read the square root of this one.
Well, we're going to talk about it because this is going to end up being a no solution one. But yeah, if it was like cosine squared x equals 1 or cosine squared x equals 1/2, yeah. But we're going to see this is the part we talked about with no solution. So you're going to take cosine squared x minus 2 and set that equals 0. How do you get rid of the minus 2?
Add 2.
Add 2. Cosine squared x equals 2. How do you undo the square? The square root. And you get cosine x equal to plus minus root 2. Cosine cannot be greater than 1. Therefore, that portion results in no solution. So when you do this, it is possible that you get a part that has no solution. Good? Alright, so that means your only two solutions would be pi over 2 plus minus and pi. That's the general solution. As we get, what? You don't need the 3 pi over 2 because if we add n pi to pi over 2, guess where we're at? 3 pi over 2. When we get closer to the quiz, we'll explain what you have to do with that. You know what I mean? So there may be questions like which ones are on 0 to 2 pi. Then you answer that. Like we're going to go through specifically so you know how to answer. So if it just says between 0 and 2 pi, then you can do that. If it asks for the general solution, then you do that. Now the third type of question would be which one of the following is a solution? Select all. And then it might be pi over 2, 3 pi over 2, 5 pi over 2. But we'll go through that before the quiz. I'm more worried about all this than I am this, because I think if we get closer and I explain that to you, it's going to be a lot easier. Sine squared x equals 2 sine x. What's your first move?
Divide by 2.
No. Subtract 2 sine x. Get them on the same side.
Oh, how stupid of me.
It happens. We'll fix it. Slowly but surely, we'll fix it. I'll fill this up real quick. You can work on the rest. Keep going. I'll be right back.
I got sine parentheses x minus 2. I got
That'll just x, because it is pi squared.
Oh yeah, and then the sine x. Wait, I got sine x and then sine x minus 2. Yeah, that's what I got. No, where's the heck is the whole class? Nobody ever comes to school anymore. Does anyone else feel like that? Like, there's no I don't know.
I mean, I didn't do much work. So.
I mean, that's also good.
All right.
Yeah.
So did you pull out the sine x?
Yeah.
All right. And so you would have sine x times sine x minus 2, right?
Yeah.
Yes, we do.
And then you got sine x is equal to 0. Sine is equal to 0 at 0 and pi. Sine x minus 2 equals 0. Sine x equals 2, just like in the last one. That one's going to have what? No solution. So our solutions, or one solution, the general would be n pi.
Wait, is sine allowed to be? Sine is not allowed to be over.
Sine and cosine cannot, they can be equal to 1. They can be greater than 1. And the reverse, secant and cosecant can't be less than 1. Tangent and cotangent can be anything they want. Okay. Everybody good? Equations of quadratic type on the interval 0, 2 pi. So these are on 0 and 2 pi. Okay? So we don't have to worry about the general ones for this. Okay, now, if you're comfortable with treating sine x as a variable, then you factor it just like that. So in other words, that becomes 2 sine x plus 1, sine x minus 1. You just factor it out.
So is it a piece different?
Yes, it's a sticker, Gia. A sticker. Okay, what are you going to do with everybody get that where that comes from?
Yes.
Now, if that's going to bother you, the sine x part, then basically what you do is you replace the sine x with a variable. In other words, if you want, you do 2w squared minus w minus 1 equals 0, where w represents sine x. And then you factor this. This would be 2w, enough room. W, this is minus 1, plus 1. And then once you factor it out, what do? You replace the w with 2 sine x. And then you replace the w with sine x. That is completely your choice. It's not required, but if that's easier for you. Okay, tomorrow you do have to do that, and we'll go through that. Hopefully we have a little bit of time at the end. All right?
Oh, I got something.
What?
The second one is a solution because it's equal to 0.
It's equal to 1. So you take each of those and set them equal to 0. I did not do that. Oh, it's over there. 2 sine x plus 1 equals 0. 2 sine x equals negative 1. Sine x equals negative 1/2. Sine x is equal to negative 1/2. It's 7 pi over 6 and 11 pi over 6. Sine x minus 1 equals 0. Sine x equals 1. X is equal to pi over 2. And then you just put them all together. Since there's no mention of the general solution, you just list the individual. All right?
Are we having this true this fall?
No. It'll be on. It'll be on. I just don't know what day. I don't know if it'll be Friday or Tuesday. Most likely Tuesday. And then if you have second questions about the review, you can answer. But I do have to talk to Kate. The problem with that is she's now home.
Coming back?
I was good too. Then I got it.
Then you got it after your spoke?
Well, my cousin got it. He got hurt. And then my dad got it. And then my whole family got it. But I didn't have anything. I was just
You're
like,
asymptomatic.
yeah. You just sucked it home.
You haven't had the test yet?
I mean, I passed the test. It's like,
I hate the test.
The nose?
Yeah, it was really like not comfortable. She
I do
said,
myself.
2 cosine squared x minus 5 cosine x plus 2.
Where is that?
on the back.
On the back. Factors in a 2 cosine x minus 1 equal times cosine x minus 2 equals 0. You take each of them and set them equal to 0. Ladies and gentlemen, if in your head you realize that for this one, how would you get rid of the negative 2?
You add 2.
And you'd have cosine x equals to 2. Can that ever happen? No, so you can cross that one if you recognize it out right away. Once you factor, In other words, once you factor to this, and you recognize that this part has no solution, you cross it out right away if you like. You don't have to show me the cosine x minus 2. That's your choice. For the other one, to get rid of the minus 1, I'd add 1. To get rid of the multiplication by 2, I would divide by 2. Cosine is 1/2 with the pi over 3 family. Cosine is positive in the first and fourth. So we end up with pi over 3 and 5 pi over 3.
I like this so much more.
Good to know.
Now, stating my opinion now.
And I'm listening. I'm hearing it. Listen, I know what parts of this are enjoyable and which ones suck. I'm listening.
How do you do like the first part, like the 2 cos x minus 1? I don't understand that part.
How do you factor?
Yeah.
I'm proud of that.
I have no idea.
Okay, it's okay. Okay, I'm not. At least outwardly, I'm not judging you one bit.
Like, I have no idea what I'm doing.
You think we're stupid right now, Jay?
So, Jay, if I were you, this is what I would do. Number one, I would change it to a variable. It'll be easier to factor that way. So you just write W equals cosine x. Okay? So now you're going to write 2W squared because you're replacing the cosine with W. Make sense?
Yeah.
Minus 5W plus 2. Okay, now, this is going to be the hard part. When you did factoring in the past, you remember how you did it, but you have no recollection whatsoever.
I remember that, like, I had a fun number that, like, I had one number and, like, something else.
We're gonna show you slide and divide. This is what slide and divide does, because it makes it easier to do that part of it that you just talked about. You take A, which is your lead coefficient, and C, which is your constant, and multiply together. 2 times 2 is 4. That's what you replace your C with. The 2W squared turns into W squared, and then the minus 5W. Now you're looking for 2 numbers that go into 4 that add up to 5. That's 4 and 1.
Yeah.
So this would be W minus 4, W minus 1. Now this is very important because kids in Algebra 1, Algebra 2, Geometry, they all forget this part. If you're going to use slide and divide, before coming up with your solutions, you need to go back and re-examine your lead coefficient, which was what? 2. You put that underneath each of the constants. You got me?
Mm-hmm.
If it goes in evenly, you divide. What's 4 divided by 2?
2.
So this becomes W minus 2. If it doesn't go in evenly like the second one, first off, you look to reduce. 1/2 can't be reduced. You then take whatever the denominator is, and you move that up to the front of the W. So that becomes 2W minus 1. And then you go back and what do you replace the W with? Cosine x. Good? That's just factor. All right. Everybody good? Okay, the last type we have involves the Pythagorean identity. All right. So you got 2 sine squared x plus 3 cosine x minus 3 equals 0. So this one's in terms of sine, this one's in terms of cosine. All right, just like when you did in 5-1 and 5-2, you always replace the squared one. You never touch the linear one. So sine squared is equivalent to what? 1 minus cosine squared x. So you substitute that in. That's all I'm doing in step 1. I'm replacing sine squared x with 1 minus cosine squared x. If you had to replace the cosine squared x, it would be 1 minus sine squared x. All right, so you have to go back and re-examine the Pythagorean identities. Now, what law would I use to simplify this part? Distributive. 2 times 1, all right, 2 times negative cosine squared x. So the negative 2 cosine squared x, the 3 cosine x stays exactly the same. All right, and then 2 times 1 is 2, 2 minus 3 is negative 1. Now, this is important for you to know. Okay? If your squared is negative, I would strongly suggest switching all your signs, which means your negative 2 cosine squared x would become 2 cosine squared x. All right?
You're 1. Like, it was negative 3 and now it's negative 1.
2 times 1 is 2.
Yeah.
When I distribute there, 2 minus 3 is negative 1. So I collected like terms. All right, so all my negatives became positives, all my positives became negatives. From there, you're just factoring. So 2 cosine squared x minus 3 cosine x plus 1 equals 0. That factors into 2 cosine x minus 1, cosine x minus 1. So that's what we've been doing all day today. All right, when I solve this one, the opposite of negative 1 is 1. Divide by 2, you get 1/2. The opposite of negative 1 is 1 there. When you see cosine is equal to 1/2, you think of the pi over 3 family. Cosine is positive in the first and fourth quadrants. First quadrant, pi over 3. Fourth quadrant is double the denominator minus 1. Cosine x is equal to 1 and x equals 0, not 2 pi. You don't use 2 pi, that's not included. So these are my specific solutions. Pi over 3, 5 pi over 3, and 0. My general solutions are listed on the right.
Where did we get the 2 from?
Which 2?
In the last part, general solution.
General solutions, because the period of sine and cosine, the tangent is just pi, sine and cosine is 2 pi. Because it goes all the way around before it becomes again. You got it?
Yeah.
Good. What do you got, that part? Okay, last one, 3 secant squared x minus 2 tangent squared x minus 4 equals 0. You can replace the secant squared x with a 1 plus tangent squared x. You distribute. All right. And you end up with that. Already at the Google Classroom that due tomorrow night. The assignment I'm giving you is already up in Google Classroom. This is what is due tomorrow night at midnight. So tonight is just the first page. This is day 2. And I'm going to give you Google Classroom for the short period so that you can join that. Does that make sense? Because we're going back and forth. And then as elastic, we'll do all this on Thursday, but just go back and make sure that all the work that you've done this marking period, that's in Google Classroom, is up to date like in Genesis. And then so that way when we delete the other one, you'll go, oh my, you know what I mean? So Thursday we'll do all that, we'll switch that way. We'll be uniform. Okay? You got one? Okay. All right. So this is basically just covering all that. All right. Both pages front and back.
So, let's do Wednesday.
Wednesday midnight. Run back and do Wednesday midnight. You show your steps. So if there's a spot where you're stuck, just you know what I mean, as you're going, so you should be showing work. If there's a spot that you're stuck, that way when you come in Thursday, first thing you do is ask questions about that. But submit your work, so at least. Okay, now the only new thing that we're doing in the lesson tomorrow. All right, just so you know. Okay? So let's say you have this, sine of 3p equals 1/2. Okay? That's going to be the difference. This is going to have like a coefficient in front of it. That's it.
What do we do?
You do what's called substitution. So you do sine x is equal to 1/2. You replace the 3t with whatever variable you want. Where is sine equal to 1/2? Pi over 6 and 5 pi over 6. All you then do is take whatever the original variable was, which in this case was what? 3t, and you set it equal to each other.
Okay.
In both cases, how would you get rid of multiplication by divided by? So you have pi over 18 and 5 pi over 18. That's it. So that's the only new thing we're doing tomorrow. If you're looking for extra help, Miss Adams will be in math lab today. Thursday, I will be after as well as virtual math lab if you're homesick. All right. So everybody knows what's due tonight. Everybody knows what's due tomorrow night.
The one that's due tonight, I just submit online.
Yes, that one you can submit online as well. They're both up there. Everything's now up there, but just in case. That way you have a hard copy of it. Guys, have a great day.
I'm gonna go watch my new Cricket show. Have a good day.
You too. Be good, guys. Mm-hmm.
I know. But I got this shirt Black Friday for like $20. And my mom found out